So before we jump into 1-6, our objective is to write and solve equations and inequalities involving absolute value. We're not going to do both of those today, so we're going to do the write and solve equations piece today, and then we'll stop. And then tomorrow you'll watch the video on write and solve absolute value inequalities. That's going to be really important because that's really the only topic in the first chapter that we do that people say, you know what, I feel like I haven't seen that one before. I don't remember having ever learned that before. So 1-6 is the one where we have to spend a little bit more time. So if you didn't already, rate yourself before the lesson on how you feel about your abilities to write and solve equations and inequalities. Yep, separated it into two. I can write and solve compound inequalities. That'll be tomorrow's. I can write and solve equations and inequalities involving absolute value. That's a little of both days in there. And then you can plop that little yellow one away. And we'll get going on 1-6. Anybody need more time reading? Okay. So 1-6 gets us to where we have to start thinking, okay, absolute value, that's special. Why is it special? Because in almost every case, there's two answers for absolute value. Because absolute value is the distance something is from zero. So if I say that I had a number that had an absolute value of 7, it could have been positive 7, but it also could have been negative 7, because there's two numbers that are 7 units away from 0. And when I said almost all of them have two answers, that's because of 0. If I ask you the absolute value of 0, it's 0. There's no two answers you can possibly get when you do that. So absolute value is the distance from 0 on a number line. We say it's non-negative. We can't say it's positive because 0 is not positive. 0 is neutral. So it's non-negative. So in numbers, 4 is how many units away from 0, everybody? 4. How about negative 4? 4. It's 4 units away from 0. So like it says in symbols, if we put a number in to the absolute value bars and it comes back out positive, that's going to happen all the time when our value for x is either 0 or positive. You just get the number right back. However, if we put a number in here that's negative, it actually makes it the opposite. You know, we put a negative 3 in, well, negative 3 is 3 units away from 0. So our answer is 3. So this little piece right here seems to be overdoing it a little bit at this level, because all we have to think of right now in Algebra 2 is, so there's two numbers for everything with 0 where the equation will work. This is actually a definition that has to be used in calculus in order to do some of the calculus you have to do. So covered more in other classes than in Algebra 2. Then, absolute value equations have a variable inside the absolute value symbol. Yep. Absolute value of x is 5. So our job is, well, what number could x be? So again, two numbers, negative 5 and 5, are both 5 units away from 0. Two answers. Now, we're going to take a test next week. And on that test, we're going to have absolute value equations. And there will be people in here that will only give me one answer. And then when they see their test, they go, oh my gosh, I can't believe I only gave one answer. That is absolute value. It's easy to forget. So remember, except for 0, absolute value has two solutions. So maybe over here on the side little lines. Except for 0, absolute value, absolute, I'm writing it as one word, absolute value has two solutions. So if you only give me one, obviously you're only getting half the points. You know, we have to give them both. Both numbers that work. So I was thinking number line again. You know, so many things we've been doing recently. It's like number line, number line, number line. Remember that. Gotta do the number line thing. Sept for 0, absolute value, has two solutions. All right. Over the years, we have seen again and again that students forget that it has two solutions. So one year, Mrs. Peterson just took a day with her class and said, can we come up with something, you know, a story, a song, something to help people remember that absolute value always has two solutions. And so her students were working on these problems all during the class, and at the end she said, did anybody come up with something that will help people remember two solutions? And one of her students is really excited. He's like, me. Okay, what do you got? The absolute value bars are like prison bars. If you're a good prisoner trying to escape, you're going to have two escape routes in case something goes wrong. You're going to have one going that way and one going that way. It helps. Prison bars. To get out of the prison bars, you have to have two escape routes. So 2x plus, I'm supposed to do that down here, aren't I? It says rewrite as two equations. 2x plus 5 could be negative 9. Because if this were negative 9 and we took the absolute value, we would get 9. But it also could be positive 9. So this is going to happen every time, because when we read this off, this really says the absolute value of something is 9. So it could have been 9, but it could have been negative 9. Again, thinking about the number line up there, 9 units, 9 units. Either way. So, jailbreak. You want to get rid of the bars? Got to have a plan for both directions. Now we just solve them. What's the first step for both of those? Second step for both of them. Divide by 2. Two beautiful solutions. So we rewrote them as two equations without the absolute value symbols, because if you want to get out of the jail bars, you got to have the two solutions. Then we solved, and those are our solutions right there. Now, we're going to graph them, which is kind of silly, so we're not going to do it a whole lot. Because they're just dots, you know, points at those places. But an absolute must with these is to check your solutions, because sometimes we're going to do all the math right, we're going to get really great answers, but they don't work. There's a fancy name for those, we're going to see it in a little bit, it's called extraneous. So we said x equals negative 7 and x equals 2 were a go. So that better work back in our original, and our original was 2 times x. That's not looking like a negative 7. Plus 5. The absolute value of that has to equal 9. Well, let's see. 2 times negative 7 is negative 14. Negative 14 plus 5 is negative 9. Is negative 7 a go? It works. It checks. I'll circle it. Now that doesn't mean I don't have to check the other one, because it's possible the other one might not work. So the absolute value of 2 times 2 plus 5, does that equal 9? Well, 2 times 2 is 4. And the absolute value of 9 is 9. Yeah, that's good. They both work. So sometimes both of them will work. Sometimes only one will work. Sometimes neither one works. And then you have to say, uh-oh, did I miss something? Should I have known right away that this doesn't have a solution to it? And then you'll go back and take a second look. So absolute value, think of it as the prison bars. 2 escape routes to get out of the prison bars. This way. We can't escape yet. And this is when the student that she had added some extra stuff. And that even made the story better. He said, because these are guards right here. They're outside the prison bars and they're guards. Nobody's going to make their escape when there's guards right there. You're right. If there's guards standing right there, why would you try to make your break for it? You got to move them. Wait till they move. So we're going to have to move the -1 and the ×3. We've done that before. We're going to add 1 to both sides. And we're going to divide by 3. Now there's no guards. Now it's jailbreak time. 2 escape routes. Notice how I'm always writing the -1 on the left and the positive on the right. It's always a good idea in math to follow the number line. You know, negatives left, positives right. Same first step and only step to solve these. Again, kind of silly. They're asking us to graph them. We graphed them. But the not so silly is we better check these. We better make sure that this stuff is going to work, because that's a pretty elaborate equation up there, and we need to see, is this going to work? Did we put a reminder down there to check? We should put our own little reminder down here. Check. So we have to check this in our original. Oh, -1 equals 8. All right. My green answer was -5. Order of operations says we got to start in those grouping symbols first, and absolute value bars are grouping symbols. So what's -5 plus 2? -3. What's the absolute value of -3? 3. What's 3 times 3? 9. -1? Oh, it works. Green one's good. Still have to check my blue. Again, we follow the order of operations. So what's 1 plus 2? 3. Absolute value of 3? 3. What's 3 times 3? 9 minus 1? Well, this one works too. We're getting super lucky here. All of them that we're doing. And you know what? That also tends to make you a little lazy about it, because you go, if they're all going to work, why are we checking all of these, you know? So every once in a while I wish they'd throw one at us that doesn't work in there, and then we'll know, hey, it's worth the check. You might get one that doesn't make this happen. All right, got a couple of got it's. Been hearing from the same people? Can't do that. Got to hear from everybody. Makes me wonder if you really don't know what 3 times 3 is. That's not good. You got to know that. Solve and graph each of the following. Absolute value of 3x plus 2 equals 4. Nevaeh, can we make a break for it right away, or do we have to move stuff over? How did you know that? Absolutely. There's no guards. There's no other numbers over there but absolute value. That's called isolating the absolute value bars. If they're by themselves, we make a break for it. Could be -4. Could be +4, because when you take the absolute value, you're going to get 4. First step for both of those, Jackson. That is exactly what we do. Second step, Mason, because you look like you're cruising ahead there. What do we do next? Oh, we got a fraction. Well, in yesterday's lesson, we found out fractions happen. You know, there's nothing we can do about it. They're going to be there. So, oh, it did say graph them again. Do all of these have that? It's kind of silly. But gives us another chance to talk about the fact that since 2/3 is not perfect, we should label that 2/3 in there. So far, so good? Hi. Doing all right? Okay. So, let's check them. We don't have a lot of space for checking, do we? We'll go up here. So, I'm going to try my red one. Landon, 3 times -2 is? Add 2 and you get? Negative, I know, yeah. -6 plus 2? Plus. So you got the -6, now move 2 back. -4. So this says the absolute value of -4 equals 4. So everybody, is the absolute value of -4 4? Red one's good. Two-thirds. We got to check that, huh? Now, let's just say you're saying to yourself, oh, fractions. I don't like doing fractions. This one's not bad to do by hand, because you can make this a 3/1 and the 3's will cancel out. But let's just say you don't even want to think about it. You don't have to, because your TI-84 Plus graphic calculator, if you put your fractions in parentheses, so 3 times the quantity 2 divided by 3, and then add 2, and hit enter, it'll give it to you. Now let's just say we did that and it came out as a fraction. It turns out that under the math button, look at number 1. It'll change anything that comes out as a fraction. Let me give you an example. 0.25, math number 1, enter. It'll change it even back to a fraction for you. So you don't have to do any fraction thinking if you don't want to do fraction thinking. The calculator will take care of it. But this certainly comes out to be 4. So they're both good. So right about now is when students are like I said before, see at home, aren't we ever going to have any that don't work? We will. Hang in there. Hang in there. Let's look at B. I think we got to do something in B before we can make our escape. Kayla, we got to do this before we make our escape. You're right, from both sides. More? Yeah, there's another guard out there. Definitely. Brandon, can we make our escapes in 2 directions now? So what are the 2 numbers we want to set this equal to? Give me the 2 numbers that are 2 units away from 0. -2 and 2. So same step for both of these. What is it, Riley? Subtract a 9 all over the place. Two very likable answers right there. I mean, they're not even fractions, but I gotta plug them in. Back up here to see if they work. So 2 times the absolute value of a -11 plus 9 plus 3 has to equal 7. So let's talk through this one. Brandon, what's -11 plus 9 right here? -2. What's the absolute value of -2? 2. So this is really going to end up being 2 times 2 plus 3. Well, that's 7. 2 times 2 is 4, and 4 plus 3 is 7. That one's good. Better check the other one. Okay, so inside our grouping symbols, which are the absolute value pieces, we've got -7 plus 9. Emma, what's -7 plus 9? 2. What's the absolute value of 2? Well, that's going to look just like this. And we know that worked. Absolutely going to work. Dropped my eraser. And then, of course, kind of silly, but, you know, we'll graph the dots. Oh, we got to go to -11, though. There. Now it goes to -11. So not only do you have to think more about how you need the 2 setups for the problem, but you also have to remember, I've got to check these, you know. And you'll have so much extra time on this test. You'll have time to go back and check your answers, make sure everything's absolutely perfect. It'll be good. So now comes the time when we need to talk about when are they going to try to slip a fastball right by us. Some absolute value equations have no solution. The absolute value of x equals -7. wait a minute. Can absolute value ever come out negative? So we can't solve that. So if we see some problem that looks like it's super challenging and fantastic, sometimes we want to say, no solution right away. Oh, but that would be dangerous in this one. Because remember, you still have to add 4 and divide by 2 before you can make that call. Then we'd see, hey, if we've got absolute value isolated on one side and there's a negative over there, done. No solutions. Isn't going to work. So this is not guaranteed. You need to isolate the absolute value. That's how you're going to know. If it says the absolute value of blah, blah, blah equals, and there's a negative number over there, nope. That's why we always check, fancy name for those false solutions, extraneous solutions, using that original equation. Go right back to the very beginning, because if we did anything wrong, we're going to catch it. We'll catch it. Hey, this got more than one number on the right-hand side. That's not fair. Well, that's when weird things start to happen. It's fair. We can still do it. It's not going to be as easy, and we definitely have to check for solutions here to make sure they work. So, let's see. In the past, I'd say whatever this is equals the negative or the positive of that. That's exactly what we do. 3x plus 2 could equal the negative of 4x plus 5. It also could equal the positive of 4x plus 5. Notice how it's getting a little more complicated. Well, now I have a negative in front of parentheses. What does that mean, everybody, when there's a negative in front of parentheses? Yeah, I'm seeing people in motion do this. You got to distribute it. It's like a -1. So you have to write the opposite of everything over here. And that's going to make it -4x minus 5. And again, when this happens, every once in a while we'll get a false solution. So now I look at it and I think, oh, well, I'd want to move over the smaller of the two x's. So I'm going to add the 4x to both sides. Now it's just a two-stepper. Subtract 2, divide by 7. Hey, it must be right. It came out as a nice integer. No. You know, we don't know if they're going to be nice integers or if they're going to be fractions or what they're going to be. So we'll do the red one and then we'll check. So with the red one, the smaller of the two variables is the 3x. Then we'd subtract 5 from both sides. Again, I don't know if it's going to work or not. I mean, I have to do the check. I have to check it and see. Is this going to work? I don't want to scroll up too far, but I want us to be able to see the original up here. So this would be the absolute value of 3 times -1 plus 2. Does that equal 4 times -1? Oops, I'm already doing the math. I hate it when I do that. Plus 5. Well, we'll do the math and we'll see. Haley, what's 3 times -1? If you add 2, what do you have? Now, what's the absolute value of -1? So this side says 1. So if the other side comes out to 1, we're okay. So, Ashley. Yeah, Ashley. What's 4 times -1? Now add -4 plus 5. Well, at least one of our answers worked. That one's good. So x equals -1 worked. Again, the red one might work too. We just have to check and we have to see. All right, the red one. But I'm going to change colors because everything seems to be running together here. 3 times -3 plus 2. We have to take the absolute value of that. 4 times -3 plus 5. Everybody looks like their heads are down. They're doing this problem. So, Marcos, 3 times -3? 3 times -3? -9. Add 2. Okay, now take the absolute value. So we have to make sure that the other side comes out to 7. Otherwise, we can't use that answer. Josh, 4 times -3? -12. Add 5 to that. Uh-oh. We found one that doesn't work. We did all the math right. We did. This one does not work. So we just put a slash through it. That way I can still see that you got the right answer when you went through there. It's just that it doesn't work, and it's called extraneous. And those things happen. They even happen in real life. In fact, whenever I have to find a goofy example of something like that happening, I just go to my husband's family. Because they seem to either not listen or something gets messed up. My husband had an uncle who was having trouble with his leg. So he lived in Faribault. He went to the doctor down there. And the doctor ran some tests, and the doctor said, you have diabetes. And when you have diabetes, then your limbs start to hurt. So he gave him, test strips and gave him prescriptions for insulin and all that kind of stuff. Taught him how to give himself insulin. And my husband's uncle went home. He did the test strips, and it said he shouldn't be giving himself insulin. It said his blood was just fine. But he gave himself insulin anyway because the doctor told him that he had diabetes. So now 3 months later, he's in the hospital. He's going to have his leg amputated. Surgeon comes in and says, okay, explain your symptoms and what's going on. And he told him the whole story. And he said, I'm going to run one more test before we do this surgery. They had marked his leg. They had already put the marks on there. It's this leg. Cut this leg off. He ran a blood test. He did not have diabetes. He had gout. If any of you guys have gout in your family, it's a situation where your body can't absorb a certain type of fat and stuff in foods, and it forms little crystals. And those little crystals try to make their way out of your leg, and that hurts when those crystals try to make their way out. But totally something you can deal with medication. And the doctor said, you don't have diabetes. We're going to send you home. We're going to treat you for gout. No, he's perfectly fine, and he still has his leg. The guy almost lost his leg, for goodness sake, from a false positive on a test. It happens. Let's look at this one. Who knows? Might be 2 answers that are both right. Might be one of them will work, one won't. Could be neither one of them works. Are we ready for the jailbreak? What do you think? Because I've gone around the room once already. Everybody, are we set for the jailbreak? No guards over there, right? It's just absolute value. So 5x minus 2 equals the negative of 7x plus 14. And 5x minus 2 equals the positive of 7x plus, ooh, I almost wrote 4. That would have really messed it up. 14. On the green one, what's the first step, everybody? Distribute the negative. Yep, it's like multiplying it all by a -1, or you can just think it's like taking opposites. Are you going to subtract 5x from both sides, or are you going to add 7x? Yeah, I would too. I like adding versus subtracting. More people make mistakes with subtracting than they make with addition, so adding is good. And it follows our rule of move the smaller one over. Then what's next? Add 2. Then we should divide. Again, a nice little answer. X equals -1. Don't know yet whether or not it works or not, but it's a nice little answer. Then we go up to the blue. What would you do to get the x's together on that one? It's a smaller one. Get it over. Easiest thing to do. Then, yep. Almost there. One more step. Again, looks like a pretty good answer. But we have to check. So I hope I left myself enough room to check. I can just squeak it in down there. All right. Absolute value of 5 times -1 minus 2. Does that equal 7 times -1 plus 14? Well, let's talk through it. What's 5 times -1? -5. Subtract 2 more. -7. What is the absolute value of -7? 7. So we better get 7 on the other side. 7 times -1? -7 plus 14? Oh, that one's good. That one is good. Doesn't mean the other one's going to work. Doesn't mean the other one isn't going to work. It just means this one was good. Absolute value of 5 times -8 minus 2. On the other side, 7 times -8 plus 14. You starting to get a feel for this? If you write down 7 times -8, don't you get a little worried? Because that's going to come out negative, right? Is there any possibility the left side of this with the absolute value bars is going to be negative? But again, you should just run through the steps just to show that you know what you're doing. 5 times -8 is -40. -40 minus 2 is -42. But the absolute value of -42 is 42. 7 times -8 is -56 plus 14, which is -42, and that is not gonna work. So like I said, 1 slash through that answer tells me you got the right answer, but it is extraneous. It's not gonna work. So this is probably the toughest stuff we've done so far this year. How are you feeling about it? We doing okay? Show me the up or down thumbs. Again, it can just be right in front of your stomach or chest there, so me and you are the only ones that see it. Okay. All right, good. So tomorrow's video will have inequalities on there. But for today, just that little baby. Wet your whistle with a few little absolute value problems right there. Apparently, I wrote on the screencast bar down here. Can't get rid of that X. Let's get that off of there. But you know now, you have to check your answers. Some of them get a little complicated. Keep that homework coming.